Have you ever wondered why AI sometimes gets simple math wrong? Like why a language model might say 2 plus 2 is 5. Recent research is changing the game, and it all starts with numbers. Here's the thing. Pre-trained language models, those big AI systems we use for writing, coding, or answering questions, have always struggled with arithmetic. But this study shows they're actually way better at understanding numbers than we thought. The key. A clever new way to read the math hidden in their internal representations. Let's break it down. These models learn to represent numbers in their embeddings, like secret codes inside their brain. But earlier methods to decode these codes were shaky, leading researchers to think the models were just bad at math. But here's the twist. The researchers discovered that these number codes follow a sinusoidal pattern, kind of like waves. Think of it as the model's internal number language, having a rhythm. Previous tools couldn't catch this pattern, but the team built a new probe that decodes these waves with near-perfect accuracy. And the results? They tested models from Llama 3 to 5.4 and OLMo 2 across billions of parameters. The new method nailed number recognition almost every time, showing these models do have precise numerical representations. Even more cool, when they adjusted the embeddings to match this wave pattern, the models got better at addition and subtraction. But here's the catch, not all models played along. One, OLMo 232b, didn't follow the wave pattern despite being good at math. So there's still mystery here. What does this mean? It suggests that AI's math mistakes might not be because they're bad at numbers, but because we've been reading their code wrong. By understanding these hidden patterns, we could make AI way better at handling numbers. So next time you see an AI stumble over a math problem, remember, it might not be the AI's fault. It could just need the right lens to see the numbers hiding in its neural network. Ever wonder how AI handles basic math? Like, can a language model really add 2 plus 2? Well, researchers recently put this to the test, and what they found is both fascinating and a bit surprising. Let's break it down. The study focused on zero-shot arithmetic tasks. That means the AI wasn't trained specifically on math problems. It had to figure it out on the spot, like you or I would if someone asked, "What's 12 times 13? The team tested models ranging from 1 billion to 32 billion parameters. And here's the kicker. The bigger the model, the better it performed, except for OLMo 2.1b, which struggled. Why does size matter? Think of parameters as the model's brain power. More parameters mean it can capture more complex patterns. The researchers found that models with more parameters made fewer errors. For example, Llama 3's 8 billion parameter version had almost no mistakes in subtraction, while the 1 billion version had a 28% error rate. It's like comparing a beginner to a math prodigy. Now here's the twist. The team didn't just look at errors, they dug deeper. They used feature attribution to see what the models were thinking when they messed up. They found that when a model got a math problem wrong, it assigned lower confidence to the answer. Imagine a student guessing an answer but unsure. It's the same idea. And even more intriguing, the same parts of the model lit up whether it got the answer right or wrong. So it's not a completely different process, it's just a matter of degree. Let's picture this. When a model adds 2 plus 2, it's like following a hidden roadmap. But sometimes the roadmap gets blurry. The researchers discovered that numbers like 0, 4, 977, and 999 were misrepresented in the model's internal code. These numbers didn't fit the pattern the model expected, leading to errors. So how did they fix it? The team tried a clever trick. They retrained the model's internal map for those tricky numbers. By adjusting how the model represented these digits, they actually improved its math skills. In one test, adding 17.6 to 23.4 went from error-prone to accurate. But here's where it gets even more fascinating. Imagine a language model trying to add two numbers. At first glance, it seems odd. After all, these models are trained on text, not equations. But recent studies show they're not just guessing. Instead, they're leveraging patterns in their internal representations. For example, models like Llama 3 and OLMo 2 use Fourier features, wave-like patterns in their data, to perform addition. It's like they're translating numbers into a language of waves, then solving the problem using trigonometry. How did researchers figure this out? They used PCA, which simplifies complex data into key patterns. When they analyzed the model's embeddings, the internal representations of words and numbers, they found sinusoidal wave-like structures, especially in models like Llama 370b. But not all models were the same. OLMo 232b, for instance, showed much less regularity, suggesting it processes numbers differently. The experiments were clever. Researchers tested arithmetic tasks by feeding the models prompts like x1 plus x2 equals, and observed how their internal heads, processing units, activated. They found that certain layers, especially later ones, played critical roles in solving problems. But here's the twist. Even though the model's input embeddings, the first layer, already contained clear numerical information, the math happened later in the network. This delay might explain why some calculations go wrong, even when the model's initial understanding is solid. What's fascinating is how these models' internal logic mirrors mathematical principles. The Fourier features act like a hidden calculator, breaking down numbers into frequencies that the model can manipulate. And when things go wrong, like incorrect addition, the patterns become noisier, almost like a distorted wave. It's a glimpse into the mind of an AI, revealing both its power and its limitations. So what does this mean for the future of AI? These insights could help build models that are better at reasoning, not just memorizing. By understanding how they think mathematically, we might unlock smarter, more reliable AI systems. And who knows? Maybe one day, your chatbot will solve calculus problems as easily as it writes a poem. Thanks for watching. If you're curious about how AI learns to think, hit subscribe for more deep dives into the science behind the tech. Let me know in the comments, do you think AI will ever truly understand math, or is it just mimicking patterns? Let's discuss.